Hello friends, let's solve another LeetCode problem. Minimum rounds to complete all tasks. So here we'll be given an array of tasks. So which will consist the difficulty level of the task. So there will be multiple numbers like for example we have 2, 2, 3, 3, then 2, then 4. So here our task is we can either complete two tasks or three tasks in a given round, and two tasks or three tasks of the same difficulty level in the given round, and we need to calculate the minimum number of rounds to complete all tasks. So here we'll have uh, as per the explanation of given example, so we'll for the there are it will take four rounds. So on the past round we'll take since there are two three numbers of twos three number of twos, so we'll take that in one round, all the twos, and then for threes there are two tasks, so we'll count that another round, and in the four we have three and then two, so these are two rounds, so these four will be completed in one round, and the next two will be completed in the next round. Let's move on to the next example. On the next one we have two number of threes and one two. These two can be completed as we are allowed to complete two tasks in a given round, but of same difficulty. But for task of difficulty two, there is only one task, and hence it can't be completed, and the output is -1. So let's solve this. So here, since we are picking tasks of same difficulty level, so what we'll do is we'll first create a dictionary or hash map, and move on all the task label and their corresponding counts. So let's start, and once we have the dictionary, we'll have the distinct tags difficulty and their counts, and based on that we'll check uh, uh, we'll try to pick how many we can pick by three tasks. Since if we can pick three tasks of same difficulty, then we can complete in minimum number of rounds. Let's take a variable rounds. It's 0, and data. This will be a dictionary of in tasks. If I in data plus equals to 1, else I equals to 1. So here we have inserted all the distinct tasks and their count into the given dictionary. Let's print it. Print data. Now we'll loop through these uh, dictionary items to generate our minimum number of rounds. So for p in data dot items, uh, here we are interested in the number of tasks. Since we have already we have already inserted the data into a dictionary uh, of so we'll have the count b of difficulty level k. So let's check if b modulo 3 equals to 0. In this case, b is multiple of 3. Hence, we can take rounds equals to rounds plus equals to integer of b by 3. Now the next case, if b is not divisible by 3, in that case we have two options. We we can end up with having a remainder 2, or we can end up having a remainder of 1. So if we are having a remainder 2, we can take two tasks in another round. Hence, we'll have rounds equals to this plus 1, because we'll take these two in another round. Let's keep it in a bracket. Okay. And let's write for next case, which is b modulo 3 equals to 1. Here, there is another check here. So if our number is 1, in that case also we'll get b modulo 3 as 1. So to avoid that case, and we'll check b greater than 3. And in this case also we'll have the same checks. We'll have b by 3 rounds first, and then we'll have plus 1 round, for the one element. And what we'll do is we'll explain that with one example. Let's see, for example, if you have four uh, four tasks of same difficulty, then we'll have remainder 1. So b by 3 would be 1. So 4 would be 3 plus 1 plus 1 will also be equals to 2 plus 2. So that means we have two rounds. We can complete in one round we'll take two tasks, and in another round we'll take two tasks. So b by 3, 4 by 3 will be 1 and plus 1 for the remaining round. So in both the cases we have this. Post that, let's check for the cases where we have a even number. In that case, if b by 2 equals to b modulo 2 equals to 0, in this case our rounds would be rounds b by 2. And if uh, for the next case, if we have modulo 2 equals to 1, in that case it could also be 1, or it could be a number greater than 1. So in that case we'll put additional check b greater than 2. If we are here, we'll have one more round. For example, if we have we won't come here, because if we have a number which is having modulo 1, is like number 3. So number 3 would be already divisible by this case. B modulo 3 would be 0. Okay. And in the else part, we'll keep rounds equals to -1, as it could be 1, because of which we cannot have any we cannot complete all the tasks. And at the last we'll return all the rounds that we have collected. Let's run. we have case 1 which is accepted. We got our expected output. Case 2, 233, which is output 0 is expected. We are we got output 0. Expected is -1. Let's see. We have only one task, and this is two tasks, so two tasks will be completed. Rounds equals to round plus 2 by 2. Okay, and 1 p equals to 1. We have modulo 1 here, and b greater than 3 not satisfied, and modulo 2 equals to 1 and b greater than 2, which is also not satisfied, and at the end we'll get else rounds equals to -1. Whenever we are I think I missed a break here. Whenever we are doing rounds -1, we need to break from the loop, as post that there might be cases where we'll get round, but because of the count, because of the data where we have a task with difficulty 1, we cannot complete that task, so we need to break and exit the loop. Let's retry. Here we got the expected result for both the test cases, and here is our complete solution. Moving the window bits, right, so that we'll be able to see it. Thank you for watching.